All right, so today we're going to start on the first question, which is the syllables. It was the question given to the both intermediate. Oops. Oh no, I lost my place in Better Call Saul. I was watching that before class. And then the tab I had there got overwritten by the ACSL problem. So let's see. There we go. Uh-oh. There we go. Okay, so it says, given a word separated into ACSL syllables using the ACSL rule. So we're not actually gonna, you know, you're not gonna actually separate them into real syllables. You just follow the rules below. And then it looks like it's pretty simple. It's very straightforward. We have 4 rules. It says separate the prefix. Luckily they do give us a list of prefixes. So I know at least what I was doing this problem with another student, and like she was asking me where are the which do I have to go into like Merriam-Webster and like list all of the prefixes? The answer is no. They give you a list. Yeah. So just remember to read the question before you start programming. But in the interest of time, I'm not going to read all of this. Like if you want someone to read this out to you, you could paste this into Google Translate and press the speech button. But anyway, we separate the prefix, we separate the suffix. After you remove the prefix and the suffix, you have to find single consonants and split before the consonant. Looks like that. Yeah, so that means the only requirement here is that there is a vowel. So like this is a pretty convoluted way of saying that there are basically a syllable consists of an optional consonant, a mandatory vowel, and another optional consonant. So complicating things a little bit is the fact that we have consonant clusters. In linguistics, they call these diphthongs. And then the problem with these diphthongs is that they make one sound, but they're represented by 2 letters like the TH. So you have to be careful. You have to be mindful of those when you're writing your program. And then afterwards, you find any double consonants. So two consonants sitting right next to each other, or 2 combo consonants. And then you split them down the middle. And they do luckily give you a list of combination consonants as well. So A, E, I, O, and U are our vowels. Consonants, note that there's no ambiguity about why. I remember learning in elementary school, they're like, the Y can sometimes be a vowel and sometimes not. In our case, we don't care. It's just Y is considered a consonant. And we have our list of combo consonants as well. You could categorize them by, there's not actually that many. Some of them start with C's, some of them not all letters have combo consonants. So like, let's say the letter B can't possibly be part of a combo consonant. It says, you'll not be given 2 consonants in a row, which is very nice of them. Yeah, so there is the problem. Hopefully you got a chance to read it before class. So the output is kind of weird, and then it was something that was kind of confusing. But the way it works is that you insert a vertical bar between the syllables, and then you basically find where the vertical bars are, and then you sum up their indices. So you could see here, it's easy to overthink this. You might be like, yeah, it's easy to overthink it, but basically all it is that you take this bar is at index 4. So the answer is 4. This bar is at index 2. This bar is at index 7. So the 7 plus 2 is equal to 9. Yeah. So don't overthink it. Like when some people started, like when my students started writing this, they're like, wait a second, like if I add this bar over here, wouldn't it shift all of the indexes forward? So don't get too hung up on that. But do definitely not only read the output, but also try to do the sample output. Like try to figure out how they got to the sample output, because that could be illuminating. All right. So we will begin writing the program. All right. Here we go. There we go. All right. So So first, we have to use our imports. No, import java.io. I'm sure most of you are using Eclipse or something similar. Do you use it? I just don't use Eclipse because my computer is going to run out of RAM if I do. The last time I opened up Zoom, oh, sorry, not Zoom, Eclipse on my computer, it took down everything on my computer. So the Zoom went down with it. And that wasn't, yeah, that took like 10 minutes of class time to work out. So I just used this text editor. So this text editor doesn't show you any typos that you make. So like if I spell something wrong or you're following along and you're like, why are there red squiggly lines underneath this? Then just let me know and I'd be more than happy to fix it. I'm going to make our static void main method. And then we will make a scanner. And then I will do in our case, it looks like we have three sample inputs, but there could be up to 10 inputs. So we'll just, instead of having a for loop that goes from 1 through 10, we'll just make it, we'll make it compatible with all numbers of inputs. So we'll just do while s.has next. There we go. And then let's see. So I am going to construct a couple of fields out in the class. That way, because I'm going to make a couple of methods to deal with this. The vowel situation, the consonant situation, stuff like that. So I'm going to put the word out here and then position and then position just for now. All right, so I'm going to make word equals s.next, and we're going to reset position to 0. Basically, we're going to start at 0. We're going to start at 0. We're going to scan the word for syllables. And then at the very end, we're going to make an array list of syllables, basically. And then at the very end, we're going to stick the vertical bars in between the syllables, and then we're going to make another loop that sums up the positions of each vertical bar. The last part is pretty simple. It's the splitting part that takes a lot of work. So anyways, speaking of an array list of syllables, let's make an array list. So we have let's see. So now what we have to do is we have to check if the word has a prefix. So luckily, they give us a list of prefixes. So I'm going to go ahead and do that. Oops. And then let's see, I'm going to copy and paste it. There we go. It takes a little bit of manual editing though. And then let's see, the next one would be suffixes. And then the suffixes are these. Okay. There we go. Okay, so we have some prefixes and suffixes. So what we're going to do is we're going to see if there is a syllable at that particular, or a prefix at that particular location. We're going to do I equals 0. We're going to scan through it. This is going to assume that there's only one prefix per word, which I think is a pretty safe assumption. Yes, because it says separate the prefix. It doesn't say separate prefixes. So let's see. So basically we're going to use the index of method. There's no reason for us to use a more complicated method. So index of these prefixes of I equals 0. That says if we could find this particular prefix at index 0, which is the beginning of the string, we will simply add we have found the prefix. Length. And we can add this to our syllables list. I like that. And then since, I mean, like the break is optional really, but I just put it there because after we find the prefix, there's no reason for us to continue looking through the array. So now we have to go and let's see. Okay, so basically basically the thing is I am not going to actually modify this string over here because in my opinion, that makes everything more complicated. So what I'm going to do is I'm going to uh, begin, I'm sorry, I'm going to scan the string between two indices. It's the index of the end of the prefix and the beginning of the suffix. So kind of in that little zone. And in order for me to do that, so what I'm gonna have a starting position and an ending position. And I'm gonna make an ending position. And then our ending position will be equal to the length of the word. We will begin by assuming that there is no ending prefix. Oops. And then so we'll scan through the prefixes, sorry, the suffixes list. And then we will do the same thing. And then in this case, the index of we're going to use last index of rather than index of, because you never know if there's the word might begin with the word less, like, like, I don't know, like if it's like, I don't even know. So you don't, or like, what if the word is like Mentos or something? So you have to use the last index of method. Oops, last index of, let's see, it's suffixes of I equals, and then the calculations here are a little bit more involved, but hopefully you could kind of see what's going on. It's not as simple as equals 0 because we're not looking at the beginning of the word. And the suffixes are all variable length, so we don't know what so unfortunately it's not a simple expression. But we do know that our ending position is equal to, let's see, is basically equal to this number, the first character the first character before the prefix. All right. So I was making this loop. If you tried this problem on your own, you may come up with a slightly better solution. It's just when I started writing this program, I didn't really think that much ahead. And I got kind of stuck with this decision. It's not a decision that makes the program wrong in any way. It's not a very, it wasn't a very good decision for me to make though. So basically I'm going to make a while loop. We're going to make while our current position is less than that of our ending position. And we aren't allowed to use the word dot length as our ending position because there might be a suffix and we're not supposed to, we don't want to double count basically. We don't want to split up the suffix. So that's why we have that ending position variable. All right. So basically what we're going to do is we're going to skip over the initial consonant if there is any. Yeah, so what I'm going to do is we are going to write a method that determines whether this character is a consonant or a vowel. So to begin, I'm going to make a method that determines whether if something is a vowel or not. I'm going to make static boolean is vowel. And then we're going to make, so basically the thing is if we go past the end of the string, we don't want to cause an exception. So we're going to silently fail if this happens. So ending, if position is greater than our ending position, we'll just return false. And then let's see. And then so the char at this particular position is word.char at position. And we'll make a quick switch statement. The switch statement is a little bit more compact. It's less typing than a bunch of ifs in a row. Case A, case E, case I, case O, case U, and then otherwise we return false. So I'm going to make two pairs of methods. So there's going to be an is vowel and there's also going to be a next vowel. The next vowel method will skip over that. If there is a vowel there, we're going to skip over it. We're going to make static void next or skip vowel. You're just going to do, since a vowel can only be one character long, it's either A, E, I, O, U. There's nothing to it. So I'm going to make a Boolean is consonant. And the consonant thing is going to be pretty much the same. It's going to be, if it's past the end of the, and if it's past the string bounds, we're just going to count it as false. So basically, it took me a while. Like initially I was like case B, case C, case D, case E. And then I realized it was a waste of time because they say a consonant is anything that's not a vowel. So basically you could just do not is vowel. So you might be like, okay, well, I could kind of see a subtle bug over here. You didn't count the double consonants, right? You were talking about like TH or, CH. So you didn't consider those here. You only look at one character because if you call this, we only look at one character here. That's true, but we don't care if it's a combo consonant. We just care if it is a consonant. And do note that all combo consonants begin with a consonant. So basically we are able to catch both over here. Yeah, at this point, we're not too concerned about the distinction between a combo consonant or a double consonant. Or a single consonant, sorry. This is the part where it gets more complicated though. So we could see if this is a consonant or not, but now we have to skip it. We have to move over this particular letter and then on to the next one. So we're gonna, we're gonna basically figure out the first character, and if that first character matches one of the letters, I believe the letters are C, P, S, T, and W. If it matches any one of those, we will check for a second consonant. And if it's there, that's great. If it's not, we'll just basically, if it's there, we'll skip forward 2. If it's not there, we will skip forward just by 1. We do want to be careful though. If we are kind of butting up towards by the end of the string, you just want to skip this particular consonant, and you don't want to, basically, if this is the last consonant before the end, you don't want to test if there's a double consonant because you might hit the end of the string. So we just go past that consonant and we'll call it a day. So we'll do a quick switch statement. If the first letter is a C, the combo consonant can either have an H or a K. All right, and then so you could basically, if it's an H or a K, we could skip forward by 2, and we will return. Otherwise, we will skip forward by 1, and then we will return. Case P, it looks like the only one that actually the only character that can follow a P to make it a combo consonant is an H, so we will do that. And then the same thing for S, it's going to be SH, so we could pretty much just copy it because it's PHSH. W is this, it's much the same as the C, except in our case, it's W, let's see, and WH and WR. We do that. So you can see that it looks like a lot of code, but there's not actually that much typing going on. Otherwise, we'll just do position ++ and then we will return if it doesn't match any of these. All right, but now we get to the meat of the algorithm. Yeah, we get to the meat of it. And I did forget to mention something. So I was testing this. So I was actually, you know what? It makes more sense if I show you the algorithm. So we will skip over the consonant. We will say is consonant. We will go to next consonant. We will skip over the consonant. I think I put next. I should put skip. And then afterwards, we're going to, let's see, we are going, okay. And you know what? And we'll just keep it nice and simple for now. We will add the complexity a little bit later. So the problem is it doesn't actually say in the problem, but it doesn't say outright in the problem statement, but if you do look at the sample input, the word choice has two vowels, but yet the O and the I are not like connected, like they're both part of the same syllable. So you have to do while is vowel. So we have to loop through, we may have to loop through multiple vowels. All right. So what we will do, basically, this is a weird way of doing it. We are basically what we're gonna do is we're gonna make an assumption. And that assumption is that the syllable ends with a consonant. And if it doesn't end with the consonant, basically we're gonna say, okay, we made a mistake. We're gonna rewind, just pretend we don't end with the consonant. So we're gonna do, so if the next letter is a consonant, you're going to assume, okay, maybe, okay, so we begin by assuming, okay, for sure, this is going to end with this syllable ends with a consonant. But we don't know if that's actually true or not. It may be that this particular consonant belongs to the next syllable. If that's the case, we want to we want to rewind. We're going to rewind equals position. We know if this particular consonant that we're seeing right now is part of the, oops, we know if it's part of this consonant or not by skipping through it. And we're going to do, oops, by looking to see if there is another vowel. So if there's a vowel after it, so if it's something like this, like if you have the word YOLO, this is going to be a consonant, this is going to be a vowel, this is going to be a consonant. But what you have to realize is that this L is not part, we are assuming that this L is part of this syllable, but it's not, it's part of the next one. Yeah, so we want to see if the letter after the L is a vowel. We need to do something called backtracking. We need to kind of say, hey, we made a mistake. We're going to take a step back and fix it. We're going to do position equals rewind. So we're going to actually rewind, go back in time. All right. All right. So what the idea is that we're going to include all of the syllables except the very last one. It's just a design choice that you make. You could make your array list contain all of the syllables, but I just made it not include all of the syllables. It was just simpler for me. Yeah, it would skip the last one. So if you want to skip the last one, you do if position is not equal to word dot length. Then we are going to do syllables dot add word dot substring. We do need to keep track of where we started. So we're going to put in starting position. And we're going to indicate that the starting position is whatever position that we started at. Starting position and then current position. And that will be that. So basically, this is a pretty simple loop. But of course, there's other complexities involved. And then you could basically what you might do, I'm not saying that you should do this, but if you're pressed for time because the programming section does involve two questions in 3 hours. If you feel like you're pressed for time, write a simple program just like this. It's not perfect. It won't work for all of them, but it's a good starting point. So what you could do afterwards is debug. So in this case, I'm not going to spend that much time debugging because I'm aware of the problems that this program has. And the very first problem is that they say you will not see two or more. It is true. You have to assume it's true. Like you can't solve the problem if the problem statement is lying to you. But what if this word begins with two consonants and they're not part of a prefix? What if it's something like black, right? There are two consonants out in front, but what we do here is we only skip one consonant. So what we want to do is if there's so this is a design, this was a design decision I was talking about, the one that wasn't quite so good. So the idea is that we begin, yeah, we begin and we skip the first consonant. Yeah, if we skip that B in black, so that when we move into the loop, we start on the L. So we know that because this loop assumes that each syllable can only start with one consonant. That's a pretty healthy assumption to make. But no, it's not always going to have only one consonant at the beginning. We're going to do next consonant. So this makes things a little bit more complicated though, because you see that there is because we do need to include the B in our final syllables list. So we're going to do a little trick over here. We're going to basically, if it's the first time around, we're not going to update the starting position. Yeah, because if the first time around, we already set it. It's set out here. So if first is equal to true, we're going to set it to false, but not update starting position. Otherwise, we're going to make we're going to basically do what we did here. Yeah. Another complexity is that, like if you have something like, I don't even know, like I'm trying to think of one. Oh, a seashell. It was one of the sample input. So if you have something like oops, a seashell, you will basically be, if you write something like seashell, it ends with two consonants. But again, our thing here is kind of wired to only deal with one consonant at the very end. So this loop kind of falls apart if you have two consonants at the beginning or the end. What we need to do here is that basically when we read our first consonant, we want to see if we hit the end of the word. Like what we will basically, the algorithm will split up seashell into something like this: C, and then shell. It will work fine because it's a double consonant. We deal with these, but it can't deal with single consonants like LL. So it will do something like this. It will split it up improperly. So this L will kind of be dangling on its own. But we don't want L to be on its own. We want to, if it's on its own, we want to kind of get rid of that syllable and stick it here, like stick it onto the previous one. So it kind of looks like that. So we're going to draw that like that. Ending position. So, we're going to do a little modification. And I'm sure if you, and again, this is not the neatest solution because I was writing this on a time crunch. But I mean, your solutions do not need to have like super clean, super amazing, the bestest algorithm of all time. All your problem needs to do, all your solution needs to do is get it right. So, and then so we will do, and we will break because there is nothing for us to do here anymore. So the end of this problem, the ending is very, very simple, and you'd be surprised by how simple it is. We're going to make a string that has our split syllables. We're going to loop through the array list. We're going to, and then we're going to add a vertical bar. I know, yes, technically the reason so that this to simplify this loop, we didn't include the last syllable. Yeah, so and then now this is our answer, this is our sum. And then so I'm just gonna copy and paste. I do have to start on the other problem. And then let's see if split syllables dot char at of I is equal. This is what I was telling you, how we would solve the problem. We do sum plus equals I, and we do system dot output sum like that. So now we have a nice robust problem. It's pretty long. It's almost 150 lines. 150 lines is not that big of a it's not that big of a program in the grand scheme of things, but it is a long program for like considering ACSL standards. Yeah, so the main thing you should kind of get out of this is that like you begin by writing a simple program, but sometimes because of unexpected events, you might have to expand the size of you might have to make your program longer. Yeah, and then so it's not a bad thing if your program is a little bit more complicated than you bargained for, because like it's not all programs are going to be simple, but definitely like but you shouldn't begin by assuming everything is going to be complicated. Add the complexity only when you realize that you need it. Yeah, so so that's why I began writing the program. Oops, the computer is telling me that I'm out of space. On my disk is running out of space. So let me do king in danger. Uh-oh. Why can't I open it up? Okay, it's opening up in the wrong program. There we go. Now it's opening up in the right one. So it is almost 8:40. The second half of your class is going to be beginning in around 20 minutes. So what I'm going to do is I'm going to get as far as I can through this. Yeah, it keeps telling me that I am it keeps telling me that like I'm running out of disk space. But okay, so we have our problem. We have a game of chess. You have to figure out if the black king is in safe, in check, in checkmate, or stalemate. You don't have to be a chess expert to know these because they are right over here. They're all defined. So I will kind of, usually I would skip this because like, I know you could read this on your own, but I do want to point out, I do want to point out a distinction though. So you can see that there's a lowercase c check and a capital C check, and that's very important, the distinction between the two. A check is like they say it over here, but a check is if a king can be captured by another piece, like if it's sitting right there. Capital C check it involves if the king is currently in check but can move to a location where he would not be in check. So that you have to make the distinction. So lowercase c check and capital C check are not the same thing. Yeah, so just be careful because it's easy to get confused. So we have this. So they give you a description of how the pieces move. I'm only going to describe it in terms of what do you call it? I'm going to describe it in terms of how we might algorithmically go about, like implementing these. But like, hopefully, you know how this kind of works. All right. And do note the numbering system that they use here. It goes A, B, C, D, E, F, G, H, but the ones start at the very bottom. If we were writing Java, a Java array, this would be index 0, 1, 2, 3, 4, and all the way up to 7. So we need some means of translating this. And we need to convert ACSL coordinates into Java coordinates. And A, B, C, D, E, F, G, H is pretty simple. Yeah, it's pretty simple. All right. So you might be like, okay, there's so many rules here. I remember last year they had a problem called Wordle. I was working on it with a student, and they're like 3 pages of just rules, rules, rules. It's like, if they begin with the consonant, then we do that. If it's this word, then we do that. But the thing is, a lot of these problems, even though they have they have a whole book written over here about like chess rules, but the thing is, you could actually distill it down. So you don't, so like they have all of, like, sure, like, yes, it's a little bit complicated in that you have many pieces, but the actual solution to the problem, it is pretty elegant. So the way I would personally do it is that they basically, if you read this enough, you kind of see that it all revolves around the king. And there's basically 2 situations that you have to keep in mind, whether the king is presently in check or if the king can, or if the spaces around the king, so these 8 boxes around the king, are in check. So basically, basically it's in either, basically you could distill it down into 2 Boolean variables, king in check, or I'm going to write it down on the screen, king in check, KIC, or spaces around king in, all of the spaces around in the king in check. So all spaces around KI. Yeah. So yeah, you could think of almost at this as like a set of like, like a Boolean expression. I know a lot of you don't like Boolean algebra. None of my students do, but you could kind of see like it's safe is if it's not in check and if it can move to a location where it's not in check. So you could imagine it's a 0-0. Check, the king is in check, so it would be a 1-0. The checkmate would be 1 and then 1-1. Stalemate is 0-1. So you could actually distill it down into this. And luckily, to figure out if it's a zero, king in check versus everybody around the king in check is very simple. You use the same algorithm to see if a square is in lowercase c check. And basically you take into account whether if this is in sorry, if you check first you check if the king spot is in check, and that's your true or false value. And then you check if each of these 8 squares is in check. And then if all of them are in check, then you put all spaces around KIC are in check, otherwise they are not. You do have to be careful. It could be less than 8. If let's say there's a pawn over here, it can't move down here. Yeah, so just be mindful of the complexities. All right. So when you start, so I'm going to try to give you an overview of how this program should be set up. It's not that complicated, but I like it. A lot of the like, if you there has to be a balance when you're programming between complexity and sorry, you need to find a balance between planning stuff out and just kind of doing what you like. Because it could be very, yeah, if you spend not enough time, uh-oh. Okay, sorry about that. I got kicked out of the meeting because apparently somebody signed in with the same account. So so I'm back. Okay, so returning to what I was saying, it's very easy to distill the problem down. It's very, very straightforward. And I wish I could find that tab again. There we go. I found the tab. Yeah. So again, just in case you didn't catch what I was saying before, the problem you could easily boil it down into you make one check method. and you give it a particular cell, like one of these. And basically it returns a Boolean. Is this space in check or lowercase c check? Or is it not in check? And then basically you apply the algorithm to where the king is, and then you square surrounding the king. And from that, you make your decision. Yeah, so you could, yeah, so it's very easy to kind of distill it down. Yeah, so you could, so in terms of how you set up your program, you want to kind of take stock of what you have right here before you actually start programming, because you may see connections if you just kind of sit down and study these rather than if you just kind of start programming immediately. If you kind of see the queen can move in, horizontally or vertically or diagonally. A rook can move horizontally or vertically. Bishop can move diagonally. You could see that the queen can move both. It's basically like an overlap of the rook and the bishop. So actually what you could simplify this program down a little bit. You write one method for rook, one method for bishop. And when you deal with the queen, you deal with, sorry. Oh, yes, I will post, to answer your question, Ian. Yes, I will post the program on Discord. Yeah, don't worry. I will post it after class is over. So so the pawn can move one forward, but it can move, you'll have to move diagonally to capture it. Yeah. Yes. One square diagonally forward. The pawn can move to c6. I'm not sure why it's telling you that the pawn can move to c6. If the enemy piece, okay. Oh, okay. So it looks like if there is an opponent in the destination square, the king can capture the piece, and the piece is removed from the board. However, the move would be legal if it results in the king's new position being in check. Okay, that was a mouthful. So our knight can move 2 spaces horizontally and 1 space vertically, or 1 space horizontally, blah, blah, blah. So you could see it's not exactly a circle, but it looks kind of like a circle. Yeah, it almost looks like a circle, but it's not like mathematical like this. Like it's not mathematical like vertical lines or like diagonal lines or whatever lines. Let me see. All right. So let us begin the program. Depending on how much, I will try to get through as much of this as possible. But I do know you guys have to do theory as well. So whenever I think Julian teacher is in the meeting. So whenever she says it is time for us to move on to, whenever she feels that it's time for us to move on to theory, that's when we will move there.
Oh, by the way, I'm not Julian teacher. I'm just using the account because
okay.
Yeah.
Oh, okay.
You can go until 9:10. Don't worry about it, man.
All right. I felt like Julian teacher was literally in here with us. I was
no, it's okay.
Okay. Yeah. Okay. Thanks for clearing that up. All right. So that's probably what kicked me out, because there's now two Chuanese inside the meeting. I came in with their account too. Yeah. No, you're good. No, you're good. I mean, there's no other way you could have done it. So yeah. So anyway, let's see. So I'm gonna make the class. This is a pretty, I'm just gonna call this king, or I'm gonna call this chess, even though the problem's called king in danger. So, because this is a chess problem. Import java.util public static void main string args. And I'm gonna make my scanner. Oops. And I did forget to read you guys I forgot to put system.in. Oh, and actually, Ian, I just thought of this. I did not actually test the program I did not test the program that I wrote, so there may be a syntax error or two, but I do have a program that I wrote earlier. It uses much of the same idea. There's more comments, but it also has some cruft in it. It's kind of crusty because I tried one solution and it didn't work. And then I tried the current solution and it did work. But then some of the previous solution kind of remains. So it's a little bit, it has some more comments in it. And then some more extraneous variables. I'll try to clean that up before I give it to you. But the other one that I worked on before is guaranteed to work. I tried it. I tried it all. And the one I wrote is neater, but it's like, but yeah, I haven't actually tried running it yet. I should probably do that at some point. But let's see. All right. So the input format, if you scroll down to page 3, is basically consists of 3-letter triplets. Yeah, separated by spaces. So you cannot use scanner.next for this because scanner.next does not make a distinction between spaces and enters. And in this case, spaces and enters do matter because enters indicates a new test case. So what we have here is that we have 3-letter triplets. The first letter is the capital. It tells you what kind of piece is there. Second letter is the column name A through I think H. And then the last one is a number 1 through 8. It's in reverse because for some reason they start 8 at the very top. All right. So I'm going to read. So basically I'm going to make a while loop. I do know they give you a template. I just don't have the template for this here. Yeah, so they would, in your real program, you would actually have they might give you an array of strings, but I don't have the template. And then I will make a string array with I'm just going to call it array s dot next line dot split on the spaces. Do be aware that yes, you could turn this into a string array and use your practice it skills, that you learned with your teachers to split the string into little chunks. But using split is so much more economical. It saves a lot of time. Because it achieves the same result. You just don't have to waste time writing it, writing this piece of code, because Java does it for you. All right. So I'm going to make a board, and then I'm going to make the board out here. So I'm going to make. So I was thinking about this, and while I was talking, and then I realized I'm going to make the board. I am going to make the board a 8x8 grid of integers. And you're like, what is this guy doing? A board new int 8x8. And again, we're going to do the coordinate flipping thing. So it starts at 8 on the top, but really it's going to start, we're going to transform that 8 into a 0. So it's basically so we don't have to flip the array upside down. So we're going to fill up the board with letters and we're going to fill it up with letters because characters are technically integers. That's why you may remember doing a practice it problem where you're adding number, you're adding you have a character variable and you're doing plus to it and it moves to the next letter because characters are basically integers. Individual characters are represented by numbers. So we could just stick them inside our int array. There's nothing that tells us it's not illegal for us to do that. All right. So let's see. All right. So we have so I am going to think about the numbering system a little bit. All right. You know what? So I'm just going, this is fine. We're going to keep it simple for now. And if I find something that requires additional complexity, we'll add it. But basically, we're going to go through the array nice and simple and then we're going to take, piece equals, let's see. Oops, it's not an array. Of I. And then we're going to do char type of piece. You got piece.char at 0. So we're going to put int, let's see, int position. Int column is going to be piece.char at of 1 minus a. Row, we're going to do some transformations here. We're going to subtract 0 to turn this character into an integer. But we're also going to flip it around. So it looks like we began, if you kind of have to think, you do have to kind of write this down. This is our original, this is what we want. This is going to be 0. If you go down to 7, it's going to be 1. And then it's 6 is going to be 2. So it looks like we could just solve this by doing, let's see. Oh God, this is, yeah. It looks like we could solve this by simply doing minus 8 minus this part 8, yeah, 8 minus this, so 8 minus that. And it won't work for, yeah, so it's all of the numbers are between 1 and 7, so I believe it should work. So now we will do board, row, and column equals type. We do want to keep track of where the king is, so we're going to do int king column, and then king row equals 0. If okay, so if type equals k for king, it's going to be king column equals column, and then king row equals row, like that. All right. So now we set up our board, so we know, yeah. So yeah, now we set up our board. So all we have to do now is figure out where we can, yeah, we're going to figure out if the square is in, yeah, if a particular square is in check or if it is not. We're going to make a public, or we don't need to make a public, static Boolean in check. We're going to give it a position. We're going to give it a row and then a column. And basically, it's going to return true if that particular square is in lowercase c check. So let me make this lowercase c. So let's see. Okay. So I am going to, yeah. So basically, we have to keep track of where the king is and where the, yeah, where the king is and where the king is. Yeah. Actually, no, we don't have to do that just yet. We just have to check if this particular cell is in check. So basically, we will loop through the entire board. 8. Or int j equals 0, j is listed 8j plus plus. And then now we put char c equals board of I and j. So now what we do is we go through a switch statement. So switch c, and then how we, okay, so if the char is 0, remember char is just an integer, so it's completely okay if you just leave it 0 here. You might get in, Java might not like it, so actually, let's do this. This is a 0 character. The 0 character, yeah, it basically represents a like the 0. Actually, I don't know. Yeah, you know what? This is, yeah, it represents the same thing as this. Yeah, 0. Yeah, you need the backslash. It's like backslash n. The backslash 0 is like the 0 character. You don't think too much into it. Yeah, and you know what? I did forget. We have to split the. Sorry, we have to clear the. Actually, you know what? I'm just gonna copy this and paste it. And then I'm gonna board of I and board of j is equal to, let's see, 0. We're gonna do that. You know what? Let's just make an int and make it simpler so we don't have to deal with the characters, the headache. We will simply continue. There's no reason for us to keep looking here. And it looks like some of the theory students have come to listen to their theory. Sorry if I'm infringing on that time. I will try to get as much of this done by 9-10 as possible. But for the people that are here doing theory, I guess you could watch me program this. Yeah, again, apologies. We're starting a little bit late. I guess you could watch YouTube too if you're kind of bored and if you don't want to watch me program. So if we have a, you know what, I'm going to start with the R. Like I said, rooks and bishops combined are the queen. So we might start with both and then move up to the queen. We have the rook. Because we're going to use a rook logic 2 times, we might as well make a static Boolean rook. Yeah, go into column. Basically, rooks go vertically and horizontally. So that means that we will need 2 for loops. We need a for loop to scan up and down, and we need a for loop to scan left and right. We will do, but the thing, this is the tricky part though. If you think about a rook, your rook cannot capture your own pieces. And that's kind of the problem here. So it seems like we would be like, we would be fine just scanning up and down, left and right, and you see if it hits any of these, but that's not necessarily the entire story. Yeah. Yeah. So we do kind of have to think about it. So actually you could break the rook motion up into 4 different categories, or you could move it, you could represent it as something going up, something going, again, for the people that are just joining, I'm going to try to stop by 9:10. I'm going to try to leave the programming people off with enough detail that they could try to implement this at home. But basically, you could break the rook motion up into up, down, left, and right. Yeah. So basically, yeah. So it's not just up and down, because what if you hit something over here? Yeah. So because my original plan was to kind of scan up and down completely, go up and down. I know this is slanted. It's because my mouse pad is slanted. But if you just scan from the very top and move to the very bottom, what if there's a pawn over here? What if the rook is right over here? That means that you're not supposed to cover this part at all. Yeah, so but if we do start from the rook and we move outwards, it becomes much simpler. We're gonna, we do need to do rook. In this case, though, we do need to keep track of the rook row and then the target row and the target column. So we're going to do rook. I believe this is this should be column. I of j and then row and column. So first we're going to go right. So in I equals 0, we're going to go right. So that means that our column is going to increase. And then I is less than 8, I plus plus. We're going to see if a board of a rook row and then I is equal to, if rook row of equal to I and rook row is equal to rook row. This is kind of melting my brain. Rook and rook column is equal to I think, yes. Then that means that wait a second. I is equal to column, or column is equal to I. This is melting my brain. We will return true because that means that we hit that particular, our rook was moving right and we hit that, we hit that particular row and column to put it in check. So we return true. Otherwise, if the board at that position, the row and a column is, and then so this is the part where you have to be kind of like, there are 2 options here that you can use. Basically, you could do if a row and column is not equal to 0 and is not equal to k. You could do that. You know what? Let's just do this for simplicity. There is a way, if you're smart enough about this, you could actually do this with a single greater than comparison. If you're careful, if you don't use k and you use a small number like 1 or 2, it will work. Yeah, it will. You could do it with if it's greater than 1, then you return true. Or we don't do return true, we do break. Because this is something that's in our way. So over here is if the king is in our way, so, or if this is our target, or and this is if something is in our way. And then so you could do the programming for the left and the right. And the really nice thing is that you could just copy and paste it and just tweak the numbers a little bit. And actually, you do want to be kind of careful. You do want to make sure that you start at rook column +1 for the right, because if you start out on the rook column, you will hit the rook itself. Yeah, and it won't work. So you want to start 1 to the right, because you will start scanning 1 to the right. And likewise here, you want to make sure it's -1. And then let's see, I'm going to move up now. This is going to be left. The comments are very important in this particular problem. Let's see. Top is going to be, let's see, rook row. Note that if we move top, the I actually goes down. And then let's do bottom. Rook row +1. And then we do, you know what, I did kind of screw up on this. This should be 0, this should be 0, and this should be less than. And this should be ++. Yeah, so you could see that this is the algorithm for the rook. And then the next one is going to be the bishop, which is going to involve diagonals. That's going to be a lot of fun to implement. So we do break. We do, let's see. So we do if the rook hit our particular spot, then we return. If we haven't, then we keep looking, basically. We don't want to just stop here. You want to, yeah, even if it's like you missed the shot, but somebody else could make it. Let's see. I'm going to let you guys do the bishop at home. It'll be a good exercise. You could actually do, you know what? I'm going to do one bishop for you, like one bishop example. Let me see. And one really cool thing about the bishop actually is, you know, before I leave, I'm going to detail this to you. Because the bishop can move diagonally, there are a couple of properties that you can use. Of course, you can make, yeah. So if you take a look over here, let me zoom in. Yeah, if you look over here, right, this is, okay, so this is, I'm going to number it the way that we numbered it. I'm not going to do any of this business with like that 8 starting at the top. And I'm going to also number it like this. Yeah, like that. So let's see that we start at this. Yeah, let's see that we start over here. This is, the bishop is at 5,2. This is just my arbitrary way of numbering things. And I do know we're out of time. If you move over here, it is 4 and 3. Actually, the pattern, it does, you know what, that there is, yeah, the pattern does not hold in this case. There was a pattern for bishops, but I guess it doesn't hold. Maybe you have to number it upside down. But basically, there is a pattern in which if you subtract, I think it might be like this. If you number it like this, 5, 4, 3, 2, 1, 0. So this would be 2, 2. This would be 3, 3. Oh yes, there it was. If you number it like this, so if you number it opposite the way that they numbered it here, you can see this is 2, 2, 3, 3, 4, 4, 5, 5. So if you're moving horizontally or diagonally, if you subtract the column number versus the row number from the column number, if you're moving diagonally, you will always end up with the same number. That's something interesting that you might want to look into. But the way I numbered it in my problem, it doesn't work. You have to number it in reverse like that. But it is something to think about. And the same thing here, if you could see that here, we would have to add them. You could see this is 0, 4, 3, 1, 2, 2, 3, 1. If you add them, you end up with the same number each time. going diagonally. Yeah, so it is 9, it's past 9:10. I have taken enough of the theory session's time. So I'm going to ask you to I will upload the code that I have on Discord. But yeah, so I will upload the code that I have on Discord. So in that case, I believe it is, let's see. Yeah, I believe, is this Sean Kim teacher?
Yep, it's teacher, I don't know, but yeah, it's me.
Okay, so it says Sean Kim teacher on the Discord. So,
Yeah, that's me.
but
Don't worry.
so I'm going to switch. I'm going to hand it over to you. I'm going to pray that my Zoom lets me export the recording after I leave
Yeah,
my, because
you just gotta stop recording.
oh,
It should
stop
download.
recording.
Yeah.
All right, sounds good. Yeah, like it's just my Zoom hates recordings. Like I was in class one time and the whole thing, like my Zoom just took an L, like it just crashed, and so I lost 2 hours of recording. So
That's
okay,